Hi everyone, welcome to the new video. In this one, I'll be covering a very important security concept in browser, which is called content security policy. If you are not aware, in the last video we covered something called cross-origin resource sharing and same origin policy. This is a bit different in regards to that. Here we talk about how browsers, even if we as a developer mess up, protects us from certain type of attacks called XSS, or you can, in simple words, you're injecting scripts or JavaScript into an actual website and running it. So this is actually a website called XSS game where you can just try out some of the payloads. So what essentially is happening is that there is a website and you can run JavaScript, which you are not supposed to. That is the main point here. So I'm just using a uh, basic payload, and if you do a search right here, you can see that hey, the execution actually happened, and I'm able to run random JavaScript code on a website that I'm not supposed to. So this is a mistake that happens a lot. The reason being that we need a lot of JavaScript and we need a lot of JavaScript, CSS, style elements, everything in the website to run. Things like these happen a lot. The browsers introduce a certain security procedure to protect against these type of malicious JavaScript executions. The problem with these JavaScript execution is that it allows us to grab all the information from this browser tab, specifically like your cookies, your tokens, whatever other informations are there. We can take all of it out of this and send it to somewhere else. So that is the main issue. So now you know the attack, and I want to kind of divert the attention into what kind of security policies are there in browsers to prevent such unsafe execution of JavaScript code. In order to explain this, we need to go back into the early 2000s. In the early 2000s, the most of the websites were static pages. There was, and it was the uh, World Wide Web boom, right? The internet boom, and thousands of sites were coming up, and all the browsers allowed JavaScript executions. So XSS attacks was really prevalent at that time. I want to take you a bit of a history here. In like 2005, some big attack happened on MySpace. It's not even an attack. It was a person called Sammy trying out a basic XSS payload, but it kind of propagated a lot over then real popular networking site MySpace. It hit over 1 million users um, in like 20 hours or 24 hours. Yeah, within 20 hours. So it's like a propagating worm, which is basically an XSS attack. So this is what was shown on victim's profile, I guess. Most of all, Sammy is my code style, and he is doing eval. So you can run. Uh, there are multiple ways that you can do uh, executions in JavaScript. One way is to use eval. So you're using eval to run this. But yeah, it's pretty cool to know that he was able to compromise a million users in that time because he was able to inject JavaScript code into the website. So that is how problematic it is. So now that we know the problem, how did actually browsers implemented a way to secure this? So in order to understand this, we need to understand what CSP essentially is, or content security policy. Any content that is being loaded in your browser tab nowadays undergoes a strict check on what all the contents there are. Now, this is actually the source of the content security policy for Chromium browser, which we all use mostly. Most of the browsers are based out of Chromium. Let's take this particular page itself. So I'm just searching for something here, but yeah, let me just leave it. So if you just check the normal reference to this page, you have all of this. Let me just go to the repeater. I have already one here. Okay, you can see all of the in the initial request, but after the initial request you can see the content security policy that is being returned by the server, that hey browser, these are all the content security policies that you need to enforce. Then they have something called script source, report sample. They have something called nonce and a hash that is there. They have unsafe inline, strip dynamic, unsafe eval, object source none, base URI self. So they have a lot of these kind of keywords telling the browser, hey, you need to cover all of this. But what essentially are all of these? So in order to go and understand all of that, we should actually look at some of the content security. So this is a main CSP file that passes all of the CSPs. The CSPs are basically like connect source, default source, font source. So you have a ton of these things. These are actually, now you can see a comment here that are CSP level 1 directory. So these actually came out in, I guess, 2012. That is the first level of protection against XSS attacks. That hey, you can only load, the default source of all JavaScript should be from this place, or script source. All the script source should be from chromium.google.com, or the whichever is your source website. Object source, media source. Are you loading any images, video, or any other medias, any other meme types? Image source specifically is there. Frame source, iframes are a big thing. You are embedding another iframe in your website, so that is there. Phone source, where are you loading your phones from? So you are actually manually declaring where all you're getting your phones, JavaScript, CSS from, and if you send anything from anywhere else, it won't execute. So that is basically the whole idea of content security policy. Then you have a level 2 directories, that kind of, so level 1 directives actually was restrictive because that was the first implementation. You only had some of these directives, that is the default source, connect source, script source. But the thing is that you wanted to load jQuery or maybe some JavaScript libraries from some other sites or many other sites, and it ends up breaking because you cannot add all of them, and they might have transitive dependencies, like it might be loading another script from somewhere else. So all of this was kind of failing. So in the level 2 directories they added a lot more to help these things out. uh, eh, that was essentially not the case. So people actually removed, instead of putting the script source, they added unsecure unsecure inline. So unsecure inline allows you to like basically run any scripts. That is kind of bypassing all of these restrictions. That is the reason why they introduced the level 2 directories. So the base URI, so you can load scripts from these all base URIs. Frame ancestors, these are protections against reflected XSS. Plugin types, which are plugin types are supported here. Form action, can you submit forms? Does the JavaScript executing form actions, is it accepted here or not? Then multiple other things. Then see, these are all they're actually checking all of these things. uh, it's really cool to go through these implementations here to understand that hey, how are browsers actually handling content security policies. And there's a cool thing that say a website is having uh, a content security policy. What if I'm loading some other child workers inside it, or maybe loading some iframes in it? So instead of again recomputing CSP again, so the website can actually transfer those CSPs to these iframes, thereby reducing a lot of computational cost. So there are like really cool ways they have done it. You can go through these CSP source. I would this is how I would actually go through it. I would actually go to the CSP directive list. So this contains the function declarations first of a lot of the functions that are used here. So then you know what all are there in the CSP directive. Then you can like specifically go into particular functions where things are done. CSP source contains most of the looks if the source actually matches what you have put in. Okay, now you don't know what that means. So if you go to the burp and they have actually given HTTPS CSP with google.com. So this is kind of a reporting URL, but I'm giving you an example here. So say if your script source is a report sample, it's matching whatever you have given as source uh, given a source. So it's kind of doing a check on what exactly is given versus the thing that is being loaded. I hope that makes sense. Yeah, that is clear, right? Yeah. Uh, so they are doing that. They are actually doing the scheme matches, the host matches. Is it from chromium.com? Is the host actually Chromium? Is the port same? Things like that. Very important stuff. Then there are a list of media directories as well, like the meme types, image, or the plugin types. So these are all added in the directive tree that is like after 2016 or 17. A lot of like child source attributes, stuff like that are added very recently. Very recently in the sense like past 8 or 9 years. Yeah. But there are some more cool stuff like, okay, now we are again looking at the Chromium source code page and the request response. You can see that see, if you're loading a lot of JavaScripts and you want to really specify only load particular JavaScripts, you can actually represent those with a hash. This was introduced because people were using a lot of inlines and evals so that they can execute whatever they want. So, and there was another thing called unsafe hashes that was introduced so that, okay, I think I'm going way off track. I'll stick to this particular one. So the nonce hash basically means that any JavaScript that you are you as a developer is going to be run on the web page is actually checked with a hash of that JavaScript, and it will only execute if that JavaScript nonce is there. So now if you go down, I think somewhere over here, yeah, there are two matches. So this is actually the hash is actually here. So I'll just click the second match. So that's one out of two. See, the script nonce is there. So that's explicitly saying um, you can run. Okay, the CSP directory will go through that. It will see the nonce. It will check if that nonce is there in the code or from wherever you're loading it. If that nonce is there, and nonce basically means that hash. Let's say that hash is there, and it will load the JavaScript based on that nonce or that hash. So it's a really safe way for you to really know that, hey, the JavaScript that I wrote or whatever I'm telling it to run is the only one that is being run. That is all about content security policies. I think you understood some of the most important security aspects in browsers, which is actually protecting you as a user. Even if developers make a lot of mistakes, uh, browsers try to fix many of that by doing all of this. And if your content security is pretty good, then even if there are vulnerabilities in your website, attackers won't be able to exploit it because your browser is protecting you. Thank you so much for watching. I hope you learned something out of it or found it really cool. If you liked it, do share it to your friends. Thank you so much. Take care. Bye.